Hello and welcome to our section 3.1 video, standard form of a line. We've split up the first section of chapter 3 into a number of different videos because it's so dense. So this is just the second chunk of information we want to cover, and it's the shortest, so buckle in and we'll get going right away. What we want to cover, what we want you to be able to do by the end of this video is you need to identify if an equation is written in standard form, and then if it's not written in standard form, be able to rewrite it so that it is in standard form. And that's it, just those two things. So we'll talk about how to do that. But before we talk about how to do it, we need to talk about what standard form is. And standard form is any linear equation written in the form ax plus by equals c. We've got a number of different rules we have to follow for this. We'll talk about those, but right now make sure you've got ax plus by equals c. That's one of those things for this chapter you just want to have in your head, locked down, ready to call up at a moment's notice. The rules. First, a, b, and c are all real numbers. That goes without saying, and yet we still always like to say it. Next, a is either positive or 0, which is a fancy way of saying that a can't be negative. Okay, a cannot be negative. We always want that first x term to be either 0 or positive when we have a standard form equation. Speaking of a being 0, a and b are not both 0. So if a is 0, then b has to be a number, and if b is 0, a has to be another number. And I don't mean to discredit 0. We all know 0 is a number, but you get what I'm saying. They cannot both be 0 at the same time. A, B, and C cannot have common factors. So for example, A is 6, B is 8, and C is 10. You'll notice those are all even numbers. They're all divisible by 2, so we have to divide them all by 2 to get it kind of simplified. Think about how fractions kind of work, that we can't have a greater common factor other than 1. It's the same thing kind of applies here. And speaking of fractions, we can't have A, B, or C be fractions. They should all be whole numbers. We won't see too many examples like that, and we'll talk about how to deal with those in class where we have to take the fractions away from the equation. The biggest ones to keep in mind are the first two. The third and fourth won't show up as often, but we'll have some examples that you can look at once we get back together in class. Now, with that in mind, as far as the rules go, we have a few complications and trip-ups, as I like to call them, just some things to keep in mind as we are practicing these. So these are some things you might write down now. Keep them handy, and when we get to our main assignment with this in class, you want to refer back to this list. First, if a function is linear, it can be written in standard form, and that also goes in the opposite direction, meaning if an equation can be written in standard form, if it looks like ax plus by equals c, then we know that function is linear. In the previous video, we talked about how to identify if a function was linear or not. This is the way to figure out if a function is linear based on its equation. Now, I say it's the way because this is the way that the book shows it, and it's always going to work, but we've covered some ways that definitely work all the time as well. So I want to put this out there, let you be aware of it. If you look in the book, you'll see it, but also remember that we have covered this already. Next, if there is no x value, then a is 0, and if there is no y value, then b is 0. Now, what that means is you'll see some of these equations where it'll just say like 7y equals 14. And you may think, oh, there's no x value, so now I don't know what a is. Well, that means that a is 0, and you will see some problems like that in the homework, so be aware. If you don't see x at all, that means a is 0. If you don't see b at all, if you don't see y at all, that means b is 0. Finally, if there is a fraction, and again, we'll go over this in class in more detail, but just jot this down. If there is a fraction, multiply everything by the denominator of that fraction, and you will get rid of the fraction. Okay, I'm just going to leave that one at that for now. We'll talk about that one more in class. But again, if there is a fraction, you multiply everything by the denominator of that fraction. Okay, let's look at an example. We have the linear equation y equals 3x plus 7, and we need to get the x term and the y term on the same side, because we know, again, we need that ax plus by equals c setup for it to be in standard form. And so the first thing we really need to have happen is get the x over to the left with y. So in order to do that, we'll subtract 3x from both sides, and this should look familiar from what we did in chapter 2 a lot. Now the 3x on the right, that should go away, and y minus 3x, those aren't like terms, so we just keep it as y minus 3x, only have a 7 on the right, and that's what we end up with as our first step. Now again, it needs to be ax plus by equals c. We right now have by plus ax, or in this case minus ax. So we want to flip those around, which you can do very easily. We just now put that negative 3x up front, the positive y in the back, and that part's done. A lot of students will get to this point and say, okay, I've got my x term first, my y term second, I'm finished. But remember, we have that list of rules, and one of the first ones is that a cannot be negative. So we have to make a positive, and the simplest way to do that is to multiply both sides by negative 1. Once we do this, you'll notice I've got the parentheses on the left and right side. Left is where it's most important, because I'll remember I have to distribute that negative 1, and that way I make sure that I get positive 3x minus y equals negative 7. And that, what we have down here at the bottom, is this y equals 3x plus 7 rewritten in standard form. That's the kind of stuff you'll be asked to do for this part of the homework. Again, there will be some more challenging problems where they throw some fractions and terms where a, b, and c have a common factor, that sort of thing. But this is the nuts and bolts of what we're doing. You get an equation in something form that looks kind of like this or something similar to it, and then you have to put it in this standard form using the tricks we learned throughout chapter 2. So jot your notes down, rewatch if you need to, bring your questions to class as always. Thank you for watching.